Hi everyone, I'm Micaiah and this is my lab report for the charge tape. A little background on the lab. The experiment required us to create a net charge on pieces of Scotch tape, as well as measure the excess charge on one piece of tape. The goals of this lab consisted of gaining a better understanding of the electric force, better known as Coulomb's law, between everyday objects and how electric fields affect matter, as well as visualizing the concept of the transfer of charge. I was able to complete the project and had to make a few edits to my code to make sure that everything that happened in my experiment was replicated correctly in my code. I identified the sign of the charge of tape to be positive, and this charge was within the same magnitude as the textbook example. And as I mentioned, I created a virtual representation of the experiment in VPython by adding functions to calculate charge and using old functions from previous labs to help me in calculating the forces. Here are my measurements. I use the initial height of tape B and the distance between tapes to find the height of tape A that was needed to create the repulsion between the tapes. And I use the tape length to help me find the mass of the tape later on. So I observed that the charged tape was attracted to the negatively charged pin, which meant that it was positive, and that the net force on tape B was zero since only the center of mass moved slightly and the tape didn't actually float. And this floating was caused by the repulsion between the pieces of tape. Here are my calculations that I mentioned. Notice that the force of gravity and the electric force are within the same magnitude, which makes sense since the net force on the tape is zero. And when I was calculating the charge, I used Coulomb's law and rearranged it and set it equal to the gravitational force to find the charge. And I ignored air resistance and treated the tape as a point particle. So here are the ratios that I found. The number of electrons on tape B was the resultant charge per electron charge. The number of atoms on the sticky side of the tape was the tape length per the atom's diameter, and the ratio of electrons to atoms was the first answer divided by the second answer. So here is a snapshot of my code. As you can see, the blue particle is tape B and the pink particle is tape A. Tape B, the orange arrow is the electric force and the green arrow is the gravitational force. There is only one force on tape A since the electric force is in the same direction as the gravitational force. So if the electrons had a positive charge and protons had a negative charge, for me, the sign of the tape would change within the experiment, but all the interactions should remain the same since everything switched signs, so everything should still be the same, and charged objects still attract neutral objects. So when handling the tape, it was imperative to not touch it as much because the transfer of charges happen through contact, and the tapes lose charge the more that they were messed with. So some interactions wouldn't happen properly. The tape would no longer repel the U tape, or it would just stick to my hand and not attract to other objects. So this lab helped me demonstrate the transfer of charge between everyday objects, as well as visualize Coulomb's law and the reciprocity of forces, and I was successful in calculating excess charges. Thank you for watching.